Hi there, my name is Mohammed Sharif, and today we'll be talking about the Cisco ACI application-centric infrastructure. The purpose of this training is to give you the foundation knowledge to be familiar with the Cisco ACI from network perspective. As you might know, that Cisco ACI is a software-defined network technology introduced by Cisco. The purpose of the SDN technology or the software defined technology is to automate your network. One of the purpose of the SDN technologies in general is to automate your network. And this is one of the features that Cisco ACI introduced. There is two approaches in Cisco ACI, the network-centric approach and the application-centric approach. Usually Cisco ACI starts with the network centric approach, and once it's done, you can take it to the next level, which is application centric approach. On this training, we are focusing only on the network centric approach. It will get you familiar with the Cisco ACI, how does it work from network perspective, how you can build up the fabric, build up the Cisco ACI, how you can integrate the Cisco ACI with any other solutions, and how you do the routing and switching and regular day-to-day activities on your Cisco ACI. I always have this question, what is the benefit of going to Cisco ACI? We can simply go to the traditional network, the Nexus 9K or the Nexus 7K. There is no big difference, okay, if we can say that between Cisco ACI and any traditional network, if we're talking about the network-centric approach. However, as I mentioned earlier, the Cisco ACI or the network-centric approach is just one step of a bigger roadmap, which eventually will lead you to the network automation and application-centric approach. With that being said, the traditional network will have some difficulties of achieving the application-centric approach, unlike the Cisco ACI, where it's provisioned to have the application-centric or the programmability or the automation, and it's ready and it's there since the beginning. However, and this is the main differentiator between the Cisco ACI and any traditional network. The Cisco ACI, as I mentioned, is one step to take you to a much further step where you can eventually end up having a fully automated network. So, as we mentioned, Cisco ACI is a software-defined network technology introduced by Cisco. Cisco ACI is also automation framework based on policy model. And here comes another differentiator between the traditional network and the Cisco ACI. Traditional network works on CLI instruction, where you want to configure some configuration or a task or something. You have to individually log into each and every component and instruct those components with the CLI to do certain activities, such as adding IP address, deleting IP address, and could be global command where it impact your entire router, or could be specific where it just impact a small portion of your network device, such as a switch interface or the router interface. Cisco ACI work differently. Cisco ACI work based on policy. You had to define the policy first before you do your configuration. You define the policy and you push it to your entire data center. And how is that done? Cisco, in order to understand how this policy model works, we have to go to the next slide and see what is the main component of Cisco ACI. Cisco ACI comprises of three main components: the APIC, the leaf, and the switches. Putting the pen here. So we have as I mentioned, Cisco ACI comprises of three main components: the APIC, the leaf, and the spine. Okay, the ABIC here, they're acting as the policy orchestrator. It's a UCS server. It's a Cisco UCS server. Okay, and it's a three servers. They're active. Okay, one at the same time. Their main purpose is to orchestrate the policies and push it to your spine and leaves or the fabric. We call it the fabric. Okay, and start applying those and managing managing the fabric as well. So the two main roles of the ABIC is to orchestrate the policies, define the policy, and push it to the push it to the fabric, and also manages the whole fabric. So you can consider the ABIC here as at the main brain, okay? And the ABIC, as I mentioned, it's just a UCS server. We have another component which is the leaf here. The leaf here is where your end hosts are connected. Here, all your server. Okay, let's say this is a database server, and this is application server. Oh, we can have this. And this is application server. So, in the leaf side here, at the leaves here, where all your hosts landed. And here all the configuration is pushed and enforced and deployed at the leaf side. We have also the spine here. The spine. The spine main purpose is to connect the leaf together, because there is a golden rule here. Never connect leaf to a leaf and never connect spine to a spine. So this is not allowed. This is not allowed. So the spine here acting as the backbone of your fabric. And what is the fabric? The connectivity between the leaf and spine, they call it the fabric here. Okay, the fabric is an underlay network. Okay, it's a layer 3 network. It can carry your traffic in a different network, which is called the overlay. So there is two new concepts here, the underlay and the overlay. We'll elaborate more about the fabric on the upcoming videos. So these three main components, the spine, leaves, the switches, this is what ACI. So you cannot consider any particular piece of those component as the ACI. All these three components have to act and operate together in order to have ACI up and running in your environment. So also one of the main purpose, with that being said, okay, ACI achieves something which is very, which is new to the technology, is having your whole data center acting as a one big switch. With the ABIC controller and leaf and spine, ABIC controller managing those leaf and spine as a one big switch, where it can validate, push the configuration, and deal with this entire fabric as a one big switch. Now what you have more manageability over your network, you have more visibility over your network, and this is one piece of component, one piece of benefit that you do not get on a traditional network. So these are the main component of the Cisco ACI, and that is their role and that is their role. So again, what is the ABIC? ABIC is a Cisco Application Policy Infrastructure Controller. It's a UCS server, usually C series, that manages the network. Control plane and management plane decisions, and you have to be very careful with the words. Only decisions are made up on the ABIC, are made up and controlled by the ABIC. Forwarding and filter policy push from the ABIC to fabric switches. Now, all the forwarding decisions, because the ACI is not the ABIC is not it's not a control plane or a data plane. It's a management server instruct the other leaves and switches, control planes and data planes to do a certain activity, which is the policy. Now, all the forwarding decision and the filtration decisions are made up by the policy, by the APIC, and pushed down to the fabric. Now, with that being said, by default, you will be no longer able to log into the switch and configure it individually through the CLI. However, CLI will be required here for troubleshooting purposes, but the main configuration will not be done from each switch individually. You have to log into the APIC, you have to configure it from the APIC and push it down to the fabric, to the entire fabric. Now, the data plane and the forwarding decisions are controlled and managed by the switches itself, because the APIC, there is no traffic flow goes. There is no traffic go through the APIC here. All the traffic goes through the switches, which is a spine and leaf. So the data plane completely managed by the spine and leaf switches. Endpoint grouping and segmentation managed by APIC, as well as filtration. So the grouping itself is managed by the APIC, okay, and pushed to the entire fabric. And we have a new concept here. Okay. We have a new concept here on Cisco ACI. We need to, it's a new terminologies introduced on Cisco ACI, which have some similarity to traditional network, but we need to fully understand it from Cisco ACI perspective. We have the endpoint group. If you ask yourself one question, how did I used to group on my traditional network? Simply via the VLAN. Used to configure the VLAN, used to configure the interfaces with certain tagged with certain protocols such as the 802.1q or ISL, and by this tagging you start to differentiate the traffic and you start to group them on a VLAN. Now Cisco introduced a new concept. It's called the endpoint group. Endpoint group, as I mentioned earlier, Cisco ACI no longer work on command line instruction, where you just log in to your router and switch and type interface VLAN or switch port VLAN access blah blah blah, and you start to adding this interface to your switch. It doesn't work that way anymore in Cisco ACI. Cisco ACI is a policy-driven technology, which means you have to define a policy. Within this policy, you can group your servers or switches. Let's say, for example, I have here are my, sorry. I have here the leaf, I have the spine, and they are all connected together. I have also here, let us change the color, the database server. I have also here the database server, and I have also here the application server. Now, since Cisco ACI is an application policy-driven technology, doesn't necessarily mean that you, with just only VLAN tagging, you can group the database admin and separate it apart from the application admin. There is a different tool and different way of doing that. We'll explain more. It goes beyond the VLAN. Okay, so it's a policy. Defined within the APIC, pushed down to the fabric, and this policy set the criteria of divisioning or separating the application servers from the database server. So the EBGs, each part of this group called the EBG or the endpoint group. So with that being said, now we can get to know more the concept of the EBG, because we will use it a lot in the upcoming videos on the ACI. So again, the EBGs, it's a grouping of servers. It doesn't necessarily mean on VLAN. It's just simply a policy which groups your end host together. Okay. Uh, Actually, if you, one of the technology, one of the prerequisite technology to fully understand ECI and how ECI works is to understand how VXLAN works. Because if you study VXLAN, it will help you a lot understanding how the fabric works and how ECI works. So VXLAN, you can say that it will help a lot in understanding. And actually, this EBG concept is I don't want to say inherited, but the EBG concept, they came from this VXLAN concept. If you can understand VXLAN, then you will understand how this grouping is done. Okay, so we have now the EBGs, the endpoint group. As I mentioned, it's a policy where you can group your servers, your end host in general. We have another concept, which is the contract. The contract is typically acting as the access list. Before, you used to have the access list to filter the traffic between interfaces and VLAN. Now you have the access list called contract, and its main role to filter between the EBGs. So each and every EBG, where is the mouse here? Okay. Each and every EBG, sorry. No. Okay. Let's say this is EBG 1. Here are EBG red. Both of them, if they want to communicate, they need to have some contract. This contract, acting as an access list, it will filter traffic. It's also a policy. This policy defines which traffic should pass through, from EBG blue to EBG red, and vice versa. So everything here is a policy. Policy define the EBGs, policy define the contract, and within this policy, okay, and within this policy also there is another policy define how the contract will work. Is it bidirectional? Is it stateful? So everything here in ECI, it's a policy. Okay, now we have now we know about the EBG. We know also about the contract. Here comes also another concept here, which is the bridge domain. What is exactly the bridge domain? As I mentioned earlier, between the switches and between the spine and leaves, or the spine and leaves, when they work together, actually they build up something called the fabric. And what is exactly the fabric? The fabric simply here we have the spine. Here we have the spine. Oh, again. Here we have the spine. Here are the leaf. Here another leaf. Okay. So between the spine and leaf, we have a layer 3 connectivity here. Okay. This is not a regular layer 2 connectivity or a regular broadcast domain connectivity where you can have the servers communicate with each other. This is a pure layer 3 connectivity. There is a routing going on here. There is eyes. With VXLAN, you can have multiple various options. Any ABG, any IGB protocol running could be OSPF, could be eyes or whatever. Here you can have eyes running between the spine and leaf. Now, with that being said, you can conclude that there is no broadcast domain here. There is no layer 2 domain here between the spine and the leaves. And here are the concept of the VLAN start to become confused. How I'm going to extend my VLAN from one switch into another. We used to trunk it before, and we used to expand our layer 2 layer 2 domain. Now we no longer have this feature because we're having the layer 3 acting on the entire fabric. With the help of VXLAN, thanks to VXLAN, we managed to tunnel, okay, the layer 2 connectivity, okay, above the layer 3 connectivity. Now, as if you're coming from a routing and switching background, you know how GRE works, correct? You have the GRE, where you can have IP carrying IP. With the VXLAN, we no longer need IP to be carried above IP. We can have MAC address carried over IP, and this is what the VXLAN does. So the VXLAN is carrying the MAC address over IP address. With that being said, what is the technique is used to extend the layer 2 across this VLAN? Actually, it's a managed technique. It's by the administrator with the help of the VXLAN to expand this the VLAN itself. But there is something here. It's no longer called a VLAN, because VLAN acting on a pure broadcast domain. It's now called the bridge domain. So the bridge domain is your expanded VLAN over the fabric. And since the fabric is a layer 3 connectivity, you cannot call it a VLAN. It's a bridge domain defined by the administrator with some certain configuration. It's defined the layer 2 domain of this VLAN across the fabric. And now we have the bridge domain. So bridge domain can have also more than multiple subnets. We have also the VRF. VRF is also a logical routing table acting as a router and switch. Within ECI, you can have different VRF, and each VRF acting as a separate router instant. We have also the tenant. Tenant also is a logical separation of the entire data center. With Cisco ACI comes, and also this is one of the key differentiator between the traditional network and the ACI. ACI introduced something called the multi-tenancy, where you can slice your entire data center and have parallel virtual data center running at the same time. For example, if you want to segregate between the DMZ, your DMZ environment, and the data center environment and the test environment, or you can have one tenant for customer A, B, and C. Also, the concept of the tenant introduced in Cisco ACI. These are the new terminologies, not all of them, but the main terminologies in Cisco ACI for the time being. So this is now for the video, for the first video. I hope this has been informative to you, and I'd like to thank you for viewing.